Example 6. Simplify this equation here. Now this is where we get tricky. This is the last thing we can have, not the last, but one of the things that's most tricky is what's called conjugates. So whenever you see this is 1 minus secant, and whenever you have the 1, the minus, the plus, typically what we're looking for is the Pythagorean identity, because the Pythagorean has the 1's and each and every trig function. Now the difference is, notice that we have a secant squared here, is that it's squared. This looks very similar to that, but it's not squared. So how do I get it? The rule is I'm going to use conjugates here. So I hope you wrote down the rules from the previous problem. Remember example 5, how I gave you these rules, which we could go back and almost add a fourth rule and say, okay, if those don't work, we look for conjugates. But we hadn't learned yet what a conjugate was. So let me come back. What is a conjugate? That is when you have something like 1 minus some value, and also somewhere else 1 plus the same value. What do? You multiply by the opposite. So here I have 1 minus secant x and I have 1 plus secant x. The way to simplify this is I want to multiply each respective fraction by what they're missing. This is missing the 1 plus secant x. So this would be 1 minus secant x times 1 plus, cosine secant x over here minus, is it just secant x? That was a mess up right there. That needs to be multiplied by 1 minus secant x over, it was 1 plus secant x. I'm going to multiply it times 1 minus secant x. Now notice how I've changed this. I've added on this parenthesis, this one over here, the 1 minus secant x. When you multiply by that, technically I'm multiplying by 1. Over here, I multiply the 1 plus secant x. So now what happens with the conjugate? Is when you multiply by a conjugate, what we're doing is if you multiply these here, actually let me go back and leave that 1 there, that 1 minus x times 1 plus x, if you FOILed this out, you go first times first, you'd end up with 1, positive x, negative x, and then negative x times positive x is negative x squared. Look what happens. These middle two terms cancel each other out. So what's brilliant about a conjugate is it changes it to 1 minus x squared. Well, in this case, x is in the place of secant x. So really what happens here is I want to distribute the top. I would have secant x plus secant squared x. That's what happens on the top when you distribute that. And on the bottom, we could FOIL it out, but I actually can use the conjugate shortcut and say this is going to FOIL to be 1. The middle two steps where you go 1 times secant and then negative secant times 1 will cancel each other out. Those go away. And then all I'm left with is 1 minus secant squared x. That's what happens there, and it'll happen in the same denominator here by using conjugates. So that's a conjugate shortcut to get from there to there. Now, what does this give us up top? When I multiply this, I get secant x minus secant squared x. Now, how are we ever going to simplify this? Let's first look at the bottom. We see we have a Pythag set up. It's kind of like Pythag. So I'm going to go over 1 minus secant squared. What is that the same thing as? We got this one here. This Pythagorean identity, which says 1 plus tangent squared. 1 plus tangent squared theta equals secant squared theta. If I wanted to get secant squared, I would move it over, and the tangent would move over to the side. So it would be 1 minus secant squared theta equals negative tangent squared theta. So that's how I'll rewrite the bottom. And when I do so, I'm also, let me just rewrite one thing at a time. Secant x plus secant squared x. Cannot combine, those aren't like terms. Over negative tangent squared theta minus, and so you see how these are like terms? You see how these have the same denominator? I'm going to make this one big fraction now. Since it's the same denominator, I can combine it. And so this will be minus secant x, and then a negative of a negative. You'd have to distribute that. So basically what happens is here, the negative gets distributed, so it becomes plus secant squared x. Okay, now let's see what I can cancel out. I have a positive secant and a negative secant. Those go away. And now I have secant squared over secant squared, which is equal to 2 secant squared x over negative tangent squared x. I messed up. This is supposed to be a theta, and now, I mean, not a theta, it's supposed to be an x. And so let me change that one. Okay, now, last thing to get the answer. I'm going to go back to the previous, earlier when we had these rules. Remember where it says switch the sines and cosines? Now that I'm here, I'm going to switch the sines and cosines. Secant is the same thing. It's the reciprocal of cosine. So I can move this to the denominator. And so what do I get when I rewrite this is I would have 2, but I would have, this becomes cosine on the denominator, cosine squared x. Tangent, I'm going to move the negative there at the bottom, is the same thing as psi y cos x. Tangent is y over x. How we can get confused, though, is when it's in the denominator, I always advise to move that up. So if I move that up, that's ugly. Let me take that away. Here. Took away too much. Negative cosine squared x. The tangent comes up and becomes cotangent. Cotangent. A lot of ugly stuff here. Squared x. Finally, psi y cos x. Tangent is y over x. This is x over y. This, one more time, cotangent becomes 2 times cosine squared x over sine goes to the bottom. Cosine squared x, sine squared x. Because, oh, that's an x, sorry. Cotangent is x over y. Now I can simplify these two, and I find out that I'm left with 2 over sine squared x, and sine squared on the bottom is the same thing as CSC in the numerator. It's its reciprocal. One more time, CSC squared x. This is my answer. Very complex to get there. I understand. It's tricky. It'll take some work, but that's how we get there. That right there is another reciprocal property. You got reciprocal identities. That's sine in the denominator. Let's find it. There it is. Sine the denominator, same thing as CSC in the numerator. And so that's how I switch from there to there. Now, there's one for you to try.